Good day, everybody, and welcome to the first Tuesday Cloud Coaching session. Today, we're going to talk about a landing zone blueprint and to put it on Onboard and run it on OCI. My name is Alexander Hödicke. I'm today's host for this session. Today, joining us are Jose and Cosmin, who are going to present the content in a minute. Before we get started, I'd just like to quickly introduce to some typical house rules, which are: all lines are muted. Please use the Zoom Q&A feature to ask questions. You can also upvote questions to put more priorities to these questions. The caption feature is enabled, so please use them if needed. If you have any questions during the live session, please use the Q&A feature of Zoom. If you have questions afterwards or you're looking for the slide deck, please contact us on Slack or reach out to us via the email address on the right side. The session will be recorded and made available on the Oracle Video Hub, as well as on our YouTube Oracle Learning channels shortly after. Please keep in mind, all of our content is presented for educational and demonstrational purposes only. And please contact sales representatives if you want to have more details and want to know more about solutions later on. We have a Slack channel available for you under the DevWell workspace. You can follow the link here, which is also shortly being posted in the Zoom chat. You will need to register with your email address and follow Slack's two-factor authentication with your mobile phone number. You can find our channel in there, which is called Cloud Coaching EMEA, where you can find the slides and can ask questions after the session. Today's presenters are Jose and Cosmin. Jose is our leader in EMEA from the pre-sales specialist organization on the topic on everything landing zone and operations. Cosmin is an operations specialist who works closely together with Jose and is the man for the hands-on stuff. With that said, I'm going to hand it over to Jose and Cosmin for their presentation. Enjoy, everybody.
Hello, everyone. I'm Jose Palmeiro, and I'll do with Cosmin this executive overview of the OCI Open LZ, a landing zone as a blueprint to onboard and run OCI. Let's kick this off. I'll switch my camera. So thank you for joining, and welcome to landing zones. For today, we will cover three topics. We will cover the decision, a very important decision, which is if you choose a standard or prescribed landing zone versus a tailored landing zone. Then we will walk through the blueprint, which will present how to guide you if you need a tailored landing zone. A tailored landing zone means custom design, your specific design. And then Cosmin will show us how to run a day two operations with configurable terraform modules. So this is what we have in agenda for today. Let's focus on the prescribed versus tailored. So this is a very, very important decision. And there's 5 steps you need to take into account to onboard and run OCI. Like a very executive summary of your journey towards onboarding and run at scale. Now, the first step, it's really about the objectives. And objectives can be mapped very easily to your requirements, right? And these areas are a very elegant way of organizing those. And you have to take into account your organization scope, how much of your organization structure will go into OCI, and how does that reflect in the segregation of duties. And obviously your workloads, which is your business value, and they can change the landing zone shape because you might have shared resources. And also your security standards, your network requirements on isolation and security, and then your operations. How is your operating model and your IT systems? So this is really the first step, then, which takes you to the approach. For the approach, you have 2 ways of doing landing zones. You can choose a standard landing zone, and that comes with a prescribed design, full of best practices in terms of security and networking. And there's actually on Oracle can choose 2 solutions. which is great. They complement each other. They are slightly different, so you can choose which one fits best. There's a CIS landing zone v2 and the OELZ v2. They both have high security standards. They have segregations of duty, isolation of resources in terms of network. So there's a lot of stuff there and that you can choose. And there's also come with code, so they're automated. So it's really no time you can set up and deploy a standard landing zone. So this is the Oracle offer in terms of standard landing zones. But we know sometimes it's not enough. And you need to go to the tailored landing zones. And you need, because you have high, very fine-tuned requirements, and you need to design on security, network operations, and also the running. For this, we have the Open LZ blueprint. I'll go into the decision in a minute on when do you go to the tailored landing zones. But you have to be aware when you go, you need skills because you're going to design. So you're going to need design and network skills and also operation skills, meaning you need to understand really well OCI. Those are the ingredients of success. Regarding the design and the run, we will do this Zoom today. So there's the next section, we'll focus on this design, and then Cosmin will focus on the run. So we'll have a Zoom here, which is actually the Open LZ blueprint is focusing on these elements. Now I want to focus a bit more on the approach, whether you go to the left or where do you go to the right. So I already discussed, right? A standard, it comes with a predefined structure, you configure, you deploy it, and sometimes you can extend it or customize it. That is done by code, right? You should always start with the standard approach, and this is what we recommend. But sometimes it's really not enough. And when it's not enough, you need to go into the tailored approach. What are examples of this tailored approach? So you can see that if your organization structure and business units need to be reflected on the landing zone, you need probably a very fine-tuned segregation of duties, and you need that to specify that some departments or business units will have some responsibilities, others have other responsibilities, and then there's also central IT. You might even have federated IT across the globe, right? And those is very hard to match directly with the standard landing zone. Likewise, for the network design, you also might find very specific requirements in terms of the security posture and all the network flows that will go from north-south and east-west. Another situation that we see is that when you need to mirror your existing landing zones on other cloud service providers, that takes us into definitely a tailoring of an OCI landing zone, so it reflects and matches your other existing landing zones. Data center exits or heterogeneous and large workloads landscape is also normally an indicator, because you might have these workloads dedicated or shared, and that brings a lot of complexity in applying a standard model. If you also want to scale your operations in terms of your operating model, probably also the standard might not be enough. So these elements are examples. There's more, but they are real and we cannot hide them, right? They are there. So those are, when you find those, you go into the tailored landing zones. And that's where we're going. That's what we want to open right now. So for the tailored landing zones, we created the OCI Open Landing Zone blueprint to guide your design. The Open LZ means Operating Entities Landing Zone, is the short for that. And operating entities, it's an abstraction that is used by a lot of our customers for line of business units, or even operating companies, especially in the telco model. Telco business has a lot of operating companies that have some responsibility on a lot of resources and some level of independence from the central IT of management of the landing zone. So the OCI Open LZ is a blueprint to simplify the onboarding of organizations, business units, and subsidiaries into OCI, right? A subsidiary might have a lot of responsibility over their resources, and they will have limitations on what they can do. This is why this design was supposed to help you. Now, this design we want to make it tangible, right? So it's a design that we will see, but it's available for you in the shape of a PDF. All the diagrams are also available for you in form of Draw.io. So you can get inspired and apply what you want from the Open LZ, use the diagrams, change them, and use them to set up your design. And you also have infrastructure scope configurations to spin that design, right? For the Open LZ that you can adjust. And Cosmin will walk us through these topics. And these infrastructure scope configurations are input to existing modules. There are 4 modules that are out there. So these modules are not done specifically for this landing zone. We leverage them. This is the CIS landing zone v3 code base. You'll find all of these elements available on this Git repository. And you see that the docs are here. There's the Draw.io, the PDF, there's the JSON examples of how to spin resources, and we'll walk through this in a bit. So everything is here for you and for you to use and tailor your landing zone. So that's why we call it tangible, because it really comes with the artifacts for you. So our objectives with the with the landing zone, with the Open LZ, is that you have a design reference to onboard your organization. We want you to lower your efforts in shorter timelines. That's why we provide all of these materials to tailor and to guide to help you drive your discussion, your design discussions. And we also propose a day 2 operating model, because sometimes the day 2 operations, they just get ignored or get postponed because it's a normally complex topic. And look, what we want to say here is, by the way, we propose this. It's not necessary we have to use it, but you can see a complete GitOps operating model on the OCI Open LZ. The OCI Open LZ, it's not prescriptive, right? It's a reference for you to adjust. So those are the objectives. Let's just walk through very quickly on the 7 characteristics of this Open LZ. So obviously it can be deployed in several regions. That's normally a situation in a lot of our customers. And you'll have shared resources for them. For each region, you need shared resources. Then you can scale horizontally as needed through the organization by onboarding new operating entities, right? That's organic growth, or decommission them. Then you can also onboard new departments and project resources. This design is also ready for multi-cloud and multi-region capabilities. You will have the design to understand how it gets connected to your on-premises, data centers, or your cloud service providers. There's segregation of duties in every layer, and you'll see it. And we put this because if you have it at the day 1, then it's very easy to make it simple and put more teams actually operating some of these areas. But later on, if you need to segregate and add additional teams with different responsibilities, well, you're ready for it. So it's a future-proof model. You also have isolation of resources in all the layers, from the shared and the hub level to the spokes, which are inside the OEs. And inside the OEs, you have also isolation per projects and environments. So you'll see that in a bit. This design also proposes, as I already mentioned, a day 2 GitOps cloud operating model. So control version Git. Everything is in Git. And as everything is in Git, we will present you, and Cosmin will show you some automation patterns. Focus on configurations to enable the expansion then of further workloads as you go. So these are the 7 characteristics. This is very highly executive, and we'll pretty soon walk into some design artifacts. Our objective here is not to explain the design, is to walk you through the key elements that you need to consider when you do a tailored design. And here they are. You have it on screen. We recommend you to follow this script. This script has the minimum valuable design for you to set up a landing zone in OCI and actually operate it. You see the functional view, which kind of sets up everyone in the same page. Then you translate it into the tenancy structure. On the tenancy structure, you decouple it into groups, policies, and compartments. So that's the identity access management. And you set up the posture manager for all your tenancy. Then you can go into the networking. And then you define the network structure. The network structure sits on top of the tenancy structure. So you already have, that's an important step. If you start first with the network, you most sure have to redesign. So this is why we recommend this flow. After the network structure, you will set up the security posture of all your network elements, which is the isolation of each of the areas, how they can communicate. And then the connectivity, how it gets connected to on-premises, and actually your traffic scenarios, north, south, and east, west. This has to be done to make sure that your landing zone has the right flow, right? At the end, this is the highways of information. If they're not clear, projects won't run. You also focus, obviously, on resolving the naming. Then you focus on the operations view, and here you define which of the cloud operations teams are working for operating actually OCI. What can they do, and how would they do it in terms of automation? And then you plug into your cloud operating model, which is control version operations, as we recommend. Let's take a look at the PDF. So the PDF, it's for you, and it contains all the design. You'll find here, as we just saw on the right, the functional view, network view, security view, network view, and operations view. This was done by a lot of our colleagues, and a note of appreciation to obviously Cosmin that is here with us, Olaf, Paulo, Paola, and Par. So you see that you have the functional, on this document, you have the functional view, then you go into the security view, and there's the compartment structures. You find a description of every element. Every element is described regarding to their objectives. You also find the groups, and the groups in every place. And then you find the networking. In the networking, you find the hub, the network structure, the hubs and spokes, and all of that. And then operations view, you also find the cloud native operations, what are the key elements inside this, which are the, as an example, you need to tailor it. And you'll find then the operation scenarios, managed services, and you'll find how the automation goes. So everything is here, and it's open for you to take a look. So this is the design document. Obviously, we won't go into explaining the design, but we explain the concepts that you need to create. So the step one is the functional view. Without the functional view, what you realize is that often you move with your design, and then you have to step back because there are some teams that haven't completely understood all the elements of OCI. So this is created for common ground. We cannot expect everyone is very fluent with OCI at the beginning. So this creates a very comprehensible view of your future tenancy. Let's take an example. And this is the OCI Open LZ. Here, there's the parent company responsibilities, you have the operating entities responsibilities. On the middle, you have shared responsibilities, right? And we created the shared responsibility concept. So because you most probably find it when you set up landing zones. So we create an example for you. So let's see what the parent company can do. They own the tenancy, and they have shared security elements and shared network elements. That's where the hub is going to stay, and all the security elements as key vaults also is going to be there. So the tenancy can have n operating entities, right? Those are your business units. They can have n of them, and each of them will have common element for networking. These will be the spokes dedicated to this operating entity. And also the infrastructure. You might find in this infrastructure share resources as Exadata Cloud Service or OKE, Kubernetes clusters, etc. And then you have environments, sandbox, development, non-prod, and production. Inside this environment, so one-to-one, right? Inside of these environments, you might have departments. You might have a lot of workloads. So departments, it's interesting if you need it to segregate responsibilities, because if you have 200 applications for one OE, probably there's different teams responsible for them. That's why the department is here. And then inside each department, you might have project environments. In each project environment, we have its application layers. So this is the Open LZ, right? It's a distributed and shared responsibility model. The OE will manage what is on the right completely. They'll have some responsibility at network level here on these elements, especially in network security groups. And the rest is done by the central IT operations. This is an example. Let me put another example, very simple, which one of our customers that we work on last month. This is a very simple one. And this is a central operations responsibility more focused. And there's only inside you focus only on the environments. And because the operating entities don't touch at all on the environments, and they just touch the projects. So everything it's managed centrally. So there's no, the OEs are at the lower level because the environments allows you to create specific policies for these environments that get inherited. So you don't have to specify it over and over for each OE. This works at the central IT, when central IT. So this is an example. There are several variations of this. But the idea is that with the Open LZ, you can create yours very quickly. If you go into the security view, so the security view translates the diagram we saw into the tenancy structure. And then we start setting up all the resources. So you have the tenancy structure, the identity and access management, and then the security posture management. Let's take a look at the Draw.io now. You have the slides here, then you can take a look at it. Let's look at the Draw.io so you have an idea. So this is all for you, or you can change them, right? You can see here the functional view, and then you have the tenancy structure. And in the tenancy structure, you already see the shared elements of the landing zone, and they're here. And then inside each operating entity, which here we have, for example, operating entities, there's always the same structure: the common elements, sandbox, development, prod, and on-prod. And here they are. This is translated directly to the compartment structure. And then, so this is up to level 2. If you go to level 5 and you need to zoom inside an operating entity, and this is a zoom inside an operating entity. You'll find here the departments, the project environments, and the layers, application, database, and infrastructure. The color code is always the same, so you can really match very easily what we're doing. So this is an example of the tenancy structure. If you want to see the identity as access management, we'll just walk you through very quickly to the groups. You'll find here how the groups are related to the compartments. So here you sort out who can do what, also with the policies. So you have all the policies identified for you. This should accelerate a lot your design. So this is the security view. After you do this security view, it doesn't mean that it's finished. You might have to revisit it, but then you can jump into the network view. And here you create 4 types of artifacts: the network structure, your network isolation and security posture, the connectivity and the traffic scenarios, and then you solve out the DNS. Let's go again to the Draw.io and follow the journey. The Draw.io is functional security network. All the diagrams sit inside the tenant with the compartments underneath. So you will not see just a tenancy, just a network view independently on these first diagrams. You see where they are, because where they are, it's actually who's responsible for them. You see who is responsible, which teams, if it's the OE team, right, or the central team to operate this. You see that each OE will have 5 VCNs. One for the common elements, environment, specific subnets, and a sandbox. You see the hub as one major VCN, and then it has 6 subnets for load balancing, north-south firewall, east-west firewall, management, logs, and DNS. This is your network structure. And this is your network structure for 2 OEs. You find 2 OEs. If you have N OEs, they'll always be the same. There's mainly 4 spokes for each OE. The sandbox, it's not connected to the DRG. And then once you do this, you should work on your security posture. Let's take an example. So the hub is a specific area of your landing zone. On each OE, the common area, it's also as a security posture. And then you have dev, non-prod, and prod, which are workload targets. They also have a security posture. Obviously, dev could have a different one. In this case, we're putting all the same level. And you have sandbox. Sandbox is a different one. So after you identify the areas, you should classify each of one regarding the security posture. You describe them, what is their objective, you see the 4 areas here, and then you define, in terms of connectivity, if they are connected to the DRG or not. The sandbox, it's not. So the sandbox is completely isolated, and you can see that the sandbox does not connect to anything. So to assess the sandbox, you need to go through the internet gateway, which is here. Also the hub as an internet gateway, which is optional. And the shared OE dedicated elements don't have access to the internet. NAT gateway is also not proposed. And service gateways, we put it because it's the way you access Oracle services, cloud services. Then the security topics, NSGs, network security groups. This is key for your security, and you cannot forget them. Obviously, they're applied at most of the layers set of the sandbox. So there's NSGs everywhere, and you see them. Also, security lists and network firewall, we consider the hub for north, south, and east, west. And at the OE, the operating entity elements, it's optional. It depends on how strong you want your posture to be between communicating 2 workloads on the same business unit. You find a zoom here for one of the areas. This is area 2, the projects. And you'll see that they all, inside an operating entity, they all share the VCN. This is the production VCN. So we're not scaling VCNs per workload. This is very important. It's very hard to operate any cloud with VCNs per workload if you have a lot of workloads or applications. The management deciders might be an impossible task. So what we're putting here is for each operating entity, they have 1 VCN per environment. And the subnets, 1 subnet for each of the layers. Now this gets secured because there's NSGs for each project for each layer. So project 1 as an NSG for applications, database, and infrastructure. And this is just to make it clear that project 1 and project 2 share the same subnet, but they have NSGs. So they're completely isolated. And this is a best practice with OCI. If you want to run at scale, there's no way you're going to make it possible with having 1 VCN per application. After this, you have north-south connectivity, north-south and east-west. This is an example. This is just now the network view. And here you can see how from your data center, you will arrive to a workload, right? You will reach the DRG. The DRG will send to the firewall. The firewall actually have to pass through to the ingress of the NSGs, will filter the traffic, and then the egress of the NSG will allow it again to hold the hub. And hub will send a load balancer from the production of target OE that actually also as an NSG. So to arrive to a load balancer, it needs to be strictly permitted. Otherwise, it won't arrive. Likewise, otherwise, it don't get egress traffic out if you don't update the NSG. This will arrive to the workload if the NSG of the workload allows it. So this is the north-south on-premise to your workload. There's also internet to the workload, and there's the east-west. I think they're very interesting. The east-west are very interesting because this is inside the same operating entity. You might choose to have if you want strong security posture inside an operating entity, you might choose to have a firewall. Here we didn't put it, but it's really your option, how hard your security posture should be. In this case, project 1 needs to communicate with project 2. They share the same subnet, but they can't communicate with each other directly because they have NSGs. So the NSG of project 1 needs to strictly allow the traffic to the load balancer. Likewise, the load balancer has also an NSG, so it needs to allow this traffic. And afterwards, the traffic will be balanced to the target project 2 endpoint, which is also NSGs. So it only arrives to project or local endpoint if NSGs allow it. You have one more inter-OE. Now imagine that you have 2 business units communicating with each other. In this case, the project workload will go to the hub. And then we'll go to the firewall. Firewall will filter, NSGs will allow or not allowed, and it will arrive again to load balancer and then workload if all the NSGs allow. So this is the network view. There's also the DNS, which we won't focus because for the sake of time. Inside the PDF on the network view, you'll find these traffic scenarios explained. And you find the flow of each element when you do ingress, when you do egress, when you are in the firewall. So this will help you to understand the flow of OCI. And ultimately, it's also a pedagogical view over OCI that will enable you really to complete your design. So this is the network view. Let's go into the operations view. So we have made a journey. We already have all the connectivity, all the highways are done and secured. Now we can decide who can do what and how will they do it. At the end, it's the cloud operations world, right? This is very important. Without this, you won't be able to scale. You might spin your landing zone, but then you'll have troubles or complexity to maintain it, or you have to do manual operations, which are always a possibility. It's really up to you. So this is just a proposal. So on the operations view, there's one key decision you need to take: code versus configuration. On code, if you decide on code, you will use existing Terraform modules and extend them or create your own modules. We saw a lot of our customers creating their own modules. This is a lot of efforts. And at the end, it's waste because there's already existing things that you should reuse. So when you go to code, your cloud operations teams will probably configure and do a bit of coding. And since your efforts, you need to code all your landing zone, it normally takes longer. So this is always viable. It depends on your skills, right? If you are already have infrastructure as code teams and they do this in no time, this might be a great way of doing it. Or you focus on configurations. And to focus on configurations, you can leverage CIS landing zone modules v3. Cosmin will show us this. This is already created for you. You can also create your own highly configurable modules, but you don't have to. It's really up to you. Or you can even create your own wrappers inside these modules. So you have service catalogs, filling directly the configuration values for your automations. Now, if you focus on configurations, mean that you focus on your design and then you can spin the configuration in no time. So we will not be coding it. You just pass JSON HCL variables, meaning that the cloud operator will use these JSON HCL variable files. This means less errors on day 2. And this is ideal for GitOps because you can version those configurations very easily. Cosmin will show us this. Now, the OCI Open LZ is one operation principle. Every change must happen through the repository. This is GitOps. This is what we recommend, but we know that every customer will have their own operating model and you should follow it, right? You should follow it, it's working, just use it. If you're in doubt or you want to check another alternatives or you don't have any scalable operating model, this is a great way of starting. So for this operating model, there are 3 key elements that I want you to take takeaways. They are the templates, configurations, and code. Now, the templates are JSON files that the cloud operator will fill whenever there's a ticket for creating some infrastructure. The cloud operator will fill and create configurations with specific values. This can also be done automatically by a service catalog, right? It depends on how much your automation and how much your self-service is available. Once you have the configurations for the specific request, you can commit them on a Git repository, and probably a pipeline will run, and the runner will put this input into the code and run it. So templates are version. For you to see an example, the OCI Open Landing Zone has 5 operation scenarios, which means a set of 5 templates. So the Open LZ gives you an example, so you can then create your own. On these templates, you have the configurations, and then it's where you put specific values. The OCI Open LZ proposes also the Git organization structure for this. And once this is committed, it will run against the code. If you take a look at the PDF and you go to the operations view, you will see the central repository structure, the OE repository structure, and maps with code colors. So from the functional view to the repository structures, you'll find always the same colors. Where are you going to put your configurations? So these are 3 different repositories, 3 different objectives. If you see this at runtime, and just before I hand over to Cosmin, so the operating model shifts to the left. It's version operations. Very few O0 code. So you have your OCI tenants with your resources. You know that you have your code, Cosmin will show us, that will actually create those resources. You have infrastructure developers, such as code developers. That can be also your cloud operators, right? But the responsibilities in each moment in time are different. The cloud operators don't touch this. The cloud operators will touch their operations repository, the blue ones. They only use the templates repository to grab the samples. And in this example, you have central operations and OE, an OE called ABC operations. Each of them have their own repositories because they have different responsibilities. So we created with the Open LZ this model, so you can see what distributed operations can look like. If you have just central operations, it's very simple. You just central ops doing everything. But they'll have a repository, and the structure of the repository will have to match the resources. In this case, the central ops is updating the DRGs, the north-south firewall, and some routing on VCNs. It commits the files, the JSON on the network configuration security. This runs a pipeline, and then the pipeline with the code and the input of the HCL JSONs, they will create your resources. The OE operations team will update, in this case, an NSG. You can see this as an example of opening a project for north-south communications. They will open the NSG at the project level. Without this, it will never arrive to the project. So they are the ultimate teams to open up their project resources. But this won't work if the hub does not allow traffic. So this are distributed operations. So when the OE ABC operations commit this, again, they will run HCL JSON configurations against the dev repository. And this same repository is used over and over again. No operations teams will touch it. They just touch JSON configurations. And this repository, this code, will run it and create your resources. So this is the version operating model. This is what we present in the OCI Open LZ. Your configurations will match your resources. Well, this is a great way of doing it because whatever you have in Git, it reflects what you have in OCI. And you might do very simple rollbacks, like a Git revert. Everything is audited by default. Whoever did something, it's there. So it's no longer the issue of who did that change. Everything is controlled and audited. So this is great security. And the auditability is fantastic. So this is why we're proposing. Being that said, now we're on the right moment to hand over to Cosmin to show us what this really, really means on the operations part. Cosmin, to you.
Thank you, Jose. Great presentation so far. So I'll take it from Jose and walk you further on through the process of taking the concepts that Jose presented earlier to you and transform them to reality. I mean, to be able to run them and provision an environment, your landing zone environment on top of OCI. So allow me to share my screen to do that. Hopefully everyone can see my screen. So the main innovation that we are bringing to you here is the one that Jose just mentioned earlier, and it will be around the separation in between code and configuration. So part of the Open Landing Zone framework that contains documentation, collaterals, recommendation and proposal for architecture, we also provide to those some terraform resources that bring you the innovation of accepting as an input any JSON configuration file parsing that natively, so there is no code generated or any other magic happening. We are just using pure native Terraform to parse any JSON TFVARS file that will allow you to specify any number of resources from one category, covering all the attributes of those resources in a JSON format. So that will enable to have one single code base that will accept as an input any topology for the specific layer that module is covering that will be specified in a familiar format, in a JSON format. So which are those modules? They are publicly available. Those modules will be the networking module, the one that you can see now on the screen. They are in the Oracle Quick Start space on GitHub, on the Quick Start organization of Oracle. The second one is the identity one. The third one is the governance one, and the fourth one is the observability one. You can use them separately, or you can use them orchestrated in an orchestrator module, right? So those are technical details. You'll be able to see how you can do them in both ways. Again, whenever you use them individually as a standalone module, you can do that. You'll find them flavored with examples. For instance, for the networking module, you'll find in here an example that contains the documentation for the example with architecture that will be deployed together with the configuration. And the configuration is looking something like this, just JSON configuration or ACL configuration. Right, and you'll find the same for all the modules that provide you with this capability. Now, you might have noticed that in the naming convention of these modules, you'll find the CIS acronym. Why you have it? Because again, those are CIS enabled, meaning that they are facilitating the implementation of the CIS standards in your architecture. It has a flag, for instance, the networking module. It has a flag to enforce for your topology to be CIS enabled or not. If you enable that flag, then automatically the module will validate for CIS security standards, and if you are having it enabled and opening ports like port 22 or port 80, it will essentially raise a warning regarding the CIS standard not being respected. And you'll find the same facility provided for all the other modules. Now, I was saying that you can you'll see now an example of how you can use these innovative Terraform modules to provision the topology that Jose presented earlier as operation entity landing zone. So let's look at that. So we'll go to a repository. Again, it's a public repository that will contain, as of now, the configuration, only the configuration, where we'll have essentially our configuration for one type of a landing zone, which is Open Landing Zone template. Why I say one type? Because it can support multiple types or any types, right, of topologies that can be landing zone topologies or any other topologies by providing just the configuration and not dealing with the code, right? So that's the aim of this. So let's look what we'll provision here. So as you have seen earlier, the landing zone topology that Jose covered contain multiple layers. We are talking about the share layer, which contain the identity and networking. For the identity, we have compartments, we have policies, and we have groups. And for networking, we have VCNs and their content, right? And then we have the OE layer and operation entity layer, and then we have the department layer, and then the project layer. Given the time constraints, I will only show you an example for the share layer that contain these two compartments here, share networking and share security, and the associated networking resources that will be provisioned in the share networking compartment. That will be the first layer I will showcase, and then the second one will be the one or multiple operation entities that will be provisioned on top of the shared one. So let's look on the on a configuration for the shared layer. We are using that for a fictitious company called Vision, right? So let's imagine that we are provisioning a shared layer for a company called Vision. So that's how that's from you see here the naming convention of Open LZ shared vision, which is the repository dedicated to provision this shared landing zone layer for this specific company and having a dedicated repository for it. So this repository will have configuration and documentation as well. So you'll be able to have the documentation that can contain graphical, diagrams, text that will be easy to be consumed by human. So the human readability factor will be very high. And that will be the documentation. And then we'll have in here also the configuration. So the configuration, it's divided into 3 separate files. And the big value added of this approach is that you'll be able to add separate permissions for each and every file that will align to your operation roles in your organization. So the first configuration there will be for a template for the credentials. So in here we'll be able to provide the credentials that will be used by Terraform to authenticate against the OCI tenancy. Then the second one will be the identity one. In the identity, you'll be able to specify the identity constructs like the compartments, groups, and policies. You see here that we are providing this in a JSON format. So how this works? You see here that I am just providing in here 2 compartments on top of the tenancy compartment, right? Just one single layer of hierarchy. But you can essentially add multiple layers in here. And let me show you how you can do that. So I'm going to Visual Studio Code because it's simple to edit in there. I'm going to the same file. And you see here that I have already added the children in here to one of the compartments, right? So I have a child added to the, to the networking compartment. I was just naming this child 01. To add the second child to this compartment, it will be like, just because I'm lazy, I'll just copy the one above. Right, and I will go here and I will add another children. I will rename the key of it to 02, and now the network compartment will have now 2 children, 01 and 02, right? And then in the same way, I can add other compartments on the same level with the existing ones, or creating sub-levels, but by using the children's attribute. Now, what you need to understand here is like in the design pattern for those modules, we are using the concept of optional resources and attributes. Meaning like if an attribute is not mandated, is not mandatory by the resource, if you do not need to specify it, we do not mandate it to be specified in the JSON file. You can just ignore it, do not specify it, and it will automatically be defaulted to null. And the same will happen for other resources as well. So if you don't specify a resource, you don't need to instantiate it to null manually. You just ignore it, and automatically under the hood it will be instantiated to null, and it will not be created. So in this way, we keep the configuration as simple as possible, while it supports a large number of resources to be created and to be provisioned in any kind of topology. So the same applies for the networking as well. So let's look how the networking layer will look like. So I'm switching to the networking file. So this looks a bit more complex. There is a complex element here called network configuration, under which I am providing a lot of constructs. One of the constructs is the VCNs. So under the VCNs attribute, I am creating one single VCN. I can create multiple VCNs, as many as I want, or none, or 0. So if I just ignore this or set this to null, there will be no VCN created. Then if I want to create a VCN, I'll create one here. And then under the VCN, I'm creating all the VCN specific attributes, including with other dependent resources. So those other attributes will be, network security groups, and I can create as many as I want. I can, for instance, if you want to add one more. So if I look here, the network security groups are quite big, right? So they contain rules as well. If I want to create one more, I'm just copying. If I want an existing one, and I'm just pasting it here, and just to, make it run and validate it. I'm just renaming it to a proper value. So yeah, now I have created another meaningless NSG. And the same goes for route tables, security list, subnets. So I have in here 4 subnets. So why 4 subnets? Because if I go back to the topology, I'm going to the README where I have the documentation. So it should be the README of the example. You see that the VCN in here contains a few subnets, right? I think there are more than 4. Let me double check in my example. Yes, I should have more than 4. So I have 1, 2, 3, 4, 5, 6 exactly as many subnets I have in the diagram itself. If I want to add one or remove it, it's a simple act of removing it or adding to this file. One extra note here is like you see here that I'm referencing other resources created as part of this automation by using their key and not a CID or the name, right? The name is not a key of unicity in OCI, so the OCID is, but I'm not using OCIDs. I'm facilitating the cross-reference between resources by offering the possibility to use keys. Under the hood, you will see that the configuration offers you the possibility to use in conjunction in the same way, at the same time, IDs and keys as well. If you don't use, IDs, you don't need to specify. Right. So let's look how this runs. Again, this is the share layer. I'll run it. I have run it previously, just not to waste time during this call for provisioning. So I'll just refresh the state, right? So you see that I'll show the command after this gets run. So this will provide me with the output file. The output file, it will be a flat structure that will show to me where everything has been provisioned. Just for this presentation, I have placed in here the output. So if you go at the end of this, you'll see how output will look like, right? And again, it will be, the output is very comprehensive, and it's a flat structure of elements that have been created that contain all the information about all the resources and the cross-references between resources, because the intention here is to make it really easy to integrate it with other modules, to be consumed by other modules. So if other modules will read from this input, it will be really easy to consume the resource created by this module.
And Cosmin, let me just add also here at one point, right? This is important and is human readable. In the case you have distributed operations, right? Because some teams doing some resources and other team responsible for other resources, this can be a great way to hand over some of the OCIDs where other teams will need to work on, right? For example, the central IT team can hand over part of this file to the operating entity team, and they already know their OCIDs of their resources. So they can work on them. They will not change it because they cannot. They don't have policies for that, but they will work on them. So it's a very comprehensible way of handover, isn't it?
Absolutely. And that's a very, very good and valid point here. It can be used outside the landing zone concept to facilitate all kinds of operations inside, and handing over of environments from one group to another. It's one of those. Right. So again, it's easy for people to consume it, and it's easy for machines, for automations to consume it. Right. So thanks for that remark, Joseph. A really good one. So moving forward, let's now see the other one. So as soon as we have provisioned the shared layer, we can now go and provision the operation entities on top of the shared layer. So you can have as many as you want. So we'll have a dedicated repository for each and every entity. The operation entities, they can start from a similar template. You can have one or multiple different templates for your OEs. You can have different categories of OEs. There is no limit in there. I mean, you can have one OE that is really different than the others. Then you can have 2 or 3 OEs that fall in one category, then another 3 or 4 that fall in a different category. So with the one that is really custom, you can start and create the configuration from scratch. But with the other ones that fall in the category, maybe you have a template and you'll start from that JSON template. And that template can be very similar to the end result, or it might need some customizations. Nevertheless, all of those, doing all of those following this approach will shorten the execution time tremendously. You will not need to code anymore. You'll have all your configuration templatized for the OEs, for the operation entities that share the same characteristics, and you'll start with the template, and you'll just change the values that need to be changed. Everything else will stay the same, including the code, and that will again speed up the team tremendously. The time to execute this. So let me just go to one OE. Again, this has his documentation, and in here we'll be creating the following. We'll have the OE compartment at the security layer that will have some sub-compartments like the OE common that will have the networking and infrastructure compartments as children compartments, and then we have the sandbox development, non-production and production compartments. So under the networking compartment here, we'll create the following networking topology, which will be a little bit more complex. Like we'll have in here 5 VCNs, and each and every of the VCN will be will contain energy, security list, and 4 subnets each, and route tables, and it will be associated with DRG in order to create a hub bespoke topology with a hub, right? That's the that's the aim here. So let's see how the configuration will look like. So I'll go directly here. So at the security level, we'll have the top OE compartment, and this will have some children, right? So let me switch from here to the Visual Studio because it's much easier to show you that in a visual manner. So if I go here, I have the top OE compartment, and underneath this one, I'll have some children. So those will be the children's. Again, the common sandbox and the ones that I have seen in the diagram. And underneath this one, I'll have the common infra and common network. And under the common network, I'll be able to create the networking. So whenever I'll create the networking resources, I will not use the the name of this compartment or of the OCI-ID. I'll just use this key to reference it. So switching back to the networking file, I'm having in here, the networking configuration, and I'm specifying here what will be the compartment that I'll be using. You can have the same compartment for all the resources to be automatically placed under, or you can go resource by resource or layer by layer and specify the compartment. There are more details in here to cover, but again, take it as they are now, and we'll follow up with a more detailed session about those, and we'll cover these things in detail. So now at the VCNs level, you see here that I have defined under VCNs, not 1, not 2, not 0, but 5 VCNs. And you can define as many as you want, right? Without changing the code. So for each and every VCN, I am defining all the VCN attributes in the same manner. If you need 0, 1, or multiple DHCP options, you can do that. And the same will be valid for subnets. So let me look for subnets. So those are the subnets in here, right? So here you go, 4 subnets. Now, and then I'll go to run this, and you'll see how this is running and performing. I will refresh it again for you to see the output. But let me add something. Maybe some of you will complain that this abstractization level is too complex. It's providing you with too many options or variables to fill in. Although it's just a JSON, you can treat it as a template. But again, maybe that claim is true for some. The way to address that is to, you can easily build a proxy module on top of this that will take this input, will hardcode most of the values, and will just expose specific values out of this. So the way of doing that will mean that to not touch any cloud provider Terraform resource. You'll just work with and part this JSON. And that's what we'll do in that proxy Terraform that you'll need to provide to oversimplify this input for creating a simplified template or for a certain category of operation entities.
And Cosmin, one observation on this topic, because it's important. The pedagogical part of these configurations is that if you know them, you know all you can do in OCI. This is extremely powerful, right? So this actually presents highly detailed all your attributes that you can change in all the resources on OCI. If you know that, you master OCI. So this is a great way of learning, isn't it?
Oh, absolutely. And then how you can correlate with what has been created in OCI. But before doing that, let me just go to the OE and let me show you the output of the the automation. So whenever you run the automation, let me just cover this first. From within the module that contains the code, you need to run terraform plan and apply against the following configuration files: the credentials, the security JSON, and the networking JSON. Right. So that's what you need to provide to your code in order to run in provision. So you'll have one code that can accept different configurations for provisioning, different topologies. Independent of the complexity of the topology and configuration, the code will stay the same. Only the configuration, the JSON will change. So moving forward, again, the same kind of characteristics of the output. The output will contain all the details about what has been provisioned. From the VCNs to, the ACP options to subnets, so on and so forth. Everything is provided in here, and each and every resource will contain details about itself and also about the other reference resources from this resource, in order to be easily consumed by other automations or by other people. Now, just let me show you that inside the OCI, and I will close with this. So, for instance, if I go here to, identity and compartments, I'll be looking for the latest compartments being created. So you see that CMP network and CMP security are the one created for the share layer, and they do not have any children. And then for the OE, we have one single OE because we didn't have the time to create more. We have all the 5 children compartments. Now that the common, we'll have the common infra and the common network. Now, if I switch to networking, I am now in the share layer in the compartment network, where I'll have the hub VCN that contains all those subnets. Now, if I go back to networking and I go to virtual cloud networks and I'll switch to OE, I'm going to the common part of it, and then I'm going to the networking. You'll see all the VCNs being created, and if I pick and choose one of them, you'll see all the subnets that have been specified as part of the configuration. So this is the approach. I would dare to say that it is an innovative approach also around Terraform, but also around infrastructure as code. We are keeping the configuration separated for the code. The code will always stay the same, and only the configuration will change. The configuration, specifying the configuration follows a well-known standard out there, which is JSON. It's another abstractization layer. It provides all the parameters to you. That's why we also consider it to be one reason for naming it Open LZ, not only because of the architecture, but also because of this kind of innovative approach in configuration and code that allows you to, with one single code base, support any kind of topology out there, independent of the complexity. That has been all from my side. Hope it was useful. Back to you, Jose.
Hey, so yeah, that open comment is really true. I forgot to comment it. It's not only because of the operating entities, because it's really open for you to use. That was a good observation. I have 2 questions for you, Cosmin. So imagine that now the customer, or partner, or any member of IT community knows already pretty well CI. So they know compartments, groups, and at least the core resources, compartments, groups, policies, and the network elements, VCNs, subnets, DRGs, route tables, network firewalls, NSGs, security lists, etc. Now they're pretty comfortable with that. How much time after the design would you think it will take to create these configurations and spin your landing zone?
Right, so assuming that's a very good question. So assuming they are skilled and assuming they are going through a really complex topology, not a simple one, a really complex one, it will be much faster for them to write a JSON than to write a Terraform code for that specific configuration. So I will say that, I don't know, maximum 8 to 16 working hours, so 2 days, will be the maximum in any situation. But if they can start from a template, like not starting from scratch to write from scratch the JSON, maybe they will find a very close template, a JSON template out there created by Oracle or by the community that is very, very similar to their use case. Then they will just edit the JSON and that be ready even in minutes or maybe 1 or 2 hours. So it really depends, but it can be somewhere in between 1 or 2 hours to maximum 8, 10, 12 hours.
Right, that's good. So another question, with this set of Terraform modules, creating groups, compartments, policies, and all the networking resources, we could mainly create all types of landing zones, can't we?
Absolutely. And not only landing zones, even what goes beyond that, right? So let's say that you have provisional landing zone, right? Using these artifacts, and you want to extend it or to create some other structure on top of them. You can use the same components in the same configuration approach, like keep the code the same and just create another configuration that goes on top of, right? And then you can separate all in layers. And those layers will align with your organization. Like use one layer that will be run for the administrators of the tenancy. Another layer will be run by the whoever manages the network, and then so on and so forth. There will be layers used by departments and by project owners that will only deal with configuration, and the code will still the same.
This is great, right? I think that's why we kind of proposed this approach to the OCI Open LZ, because it's really ideal when we help you out on your design to make it faster. And then with this approach, you can spin your landing zone in no time. And it's not about just deploying your landing zone. It's about running, right? You have to think about running. And running you can deploy your landing zone, but then if you're going to run it with the console, you're hardly going to scale. Right, it's going to be very chaotic and time consuming. So this solves the day one, which is the deployment, and the day two of the running. So thanks a lot, Cosmin. I'm going to put just one more wrapping slide, and then I hand over to Alex. So this was seen. Okay, wrapping up. So some highlights that we want you to take, right? Not everyone needs tailored landing zones. This is important, right? A tailored landing zone can be very, very simple, but can be also very, very complex. It depends on your requirements. Please consider those. A standard approach is a great way of starting to get to know OCI, to set up a very secured architecture. So please consider those options before jumping into a tailored design. The OCI Open LZ guides all the design activities, and its objective is to reduce your efforts and time. That's why we're providing the PDF with all the steps, the functional view, security view, network view, and operations view. It's not prescribed. It's for you to use, adjust, remove, update, do whatever you need, right? But you have a reference model with a coherent story end to end. So the functional view connects even to the operations view, which is at the end. Through the OCI Open LZ, you'll find that all the code colors are the same, and you easily find each of the elements inside each of the architecture view. So this is supposed to guide you and reduce your efforts. We've seen some of our customers and partners designing landing zones that they can take often a lot of time, and especially implementation can even take longer. So that is why we put this approach. The point 4 is the CIS landing zone with 3 modules. You can, as you've seen and Cosmin showed us, you can quickly create any landing zone you want or any core resources, right? And the most elegant part is that this is ready for day 2 operations with version configurations. So the JSONs are HCL native JSONs. You can version them, and they're just input to the code. This is a great approach to simplify your implementation and your running. So this is a bit of the highlights we want to take. Here are some useful resources. There's the Git repository. Now the link already works. Sorry for that. So it contains the PDF, the draw.io, and the examples that Cosmin showed us. You can also reach out to me and Cosmin anytime. We use those Terraform modules for the demonstration, the IAM and the networking, and take the links for the standard landing zones because we do think they're important for you to consider before starting. Alex, to you.
Right. Thank you very much. We are at the end of our presentation. Jose, Cosmin, fantastic presentation. Thanks a lot. Everybody, I'm just going to launch a quick poll for you to respond, to have a look while I'm going through the last closing slides. So, just want to go forward. Well, here we are. Please join us now also every Tuesday, additionally to Wednesday, for the next cloud coaching sessions. So, for example, tomorrow we have on Wednesday, Unveiling the Power of OCI Observability, a short tour and best practices for effective implementation. Find the QR code on top and the link. You find the slides, of course, in Slack later. Also, keep in mind, Tuesdays, we're now running these sessions as well. We will add on our website more sessions and slots for the next couple of Tuesdays going forward. We will also have a boost one-to-one call with the presenters from today on the 19th of June, 10 o'clock CET. You can sign up for these slots there, 10 o'clock and 10:30, to speak with Cosmin and Jose about what you saw today. Please keep in mind, it's a general discussion about landing zones, not other topics, and not sales support, general support, or implementation support. It's a high-level discussion on the landing zone topic. You find details in chat. With that said, these are all of our additional resources we always share at the end of these sessions. Again, you will find PowerPoints, the PDF version of the PowerPoint in Slack. And you can find all of these links for previous previous cloud coaching sessions, tracks, videos, live sessions from previous things. With that said, thanks everybody for attending today. Please go to our Slack, reach out to us, or write us an email, and we see each other on the next session. Thanks everybody, and goodbye.